Welcome to Miyconst Hardware. This is going to be part 2 of me testing this Huananzhi H12 AMD EPYC motherboard. The motherboard itself is still on my test bench, and for this video I tested it during several weeks, so I have a few pre-recorded video chunks that I will inject down the line, so please forgive me if something will be a bit oddly edited or inserted. So I have collected many different questions, and mostly they are server related or server features related. I have the printout, so let's get it started. One of the most frequently asked questions on Discord and in YouTube was about the memory I used with my motherboard and CPU, because AMD EPYC CPUs might be picky with RAM. So I used Samsung 32GB DDR4-2933 PC4-2933Y 2RX4 memory modules, 8 of them in specific. The exact model number I will show on the screen, or you can read it in the comments, because I just don't want to say this whole model number. Another question was if the motherboard is actually reporting ECC errors, if the ECC errors are detected, corrected and reported. And I have to say, yes, it indeed does that. So I used Memtest86, and it turns out that one of my memory modules is semi-defective because it is constantly spinning out ECC errors which are getting corrected, and Memtest86 detects that and reports that. The test still passes, but there are ECC correctable errors. Additionally, I can say that Memtest86 also spits out a couple of additional errors which are like UEFI firmware error, could not start CPU, one CPU whatever entry. I googled a little bit, and it seems to be like some sort of a UEFI bug when Memtest is running in multi-threading configuration, which doesn't seem to affect real operating systems. So I'm not sure how critical it is, but other than in Memtest, the motherboard and the CPU worked pretty solid without a single crash under my testing. The motherboard drivers is another concern that some of you might have, and in my original review I reported that Huananzhi website is pretty slow and not accessible in several locations outside of China, so that's why I duplicated the official Huananzhi drivers to my Microsoft OneDrive, and it turns out that you can actually use drivers for Supermicro H12 motherboards. In particular, I have tested Supermicro drivers for H12 SSL-C motherboard, and they do indeed work because it is the same platform and basically the same chipset or system on chip, because AMD EPYC CPUs include chipset on the CPU itself. The next point in my list is dedicated to motherboard's IPMI or BMC. As I have shown in my first video, the motherboard comes with a removable BMC, which is SPEED AST2500, and people ask me to explore the interface and see what kind of freedom or flexibility we can get. So here I'm going to inject a pre-recorded video where I walk through the BMC interface, but first I would like to mention that if you disable BMC in the BIOS, then the motherboard boots up a bit faster. In particular, in my measurements, the motherboard boots up in about 90 seconds faster or 1.5 minutes faster compared to when BMC is enabled. Okay, let's go through BMC or IPMI interface of Huananzhi H12 EPYC motherboard. The dashboard is pretty simple. We don't really have much meaningful information here, except of these critical sensor errors, and that's because I don't have all the fans connected. In the sensor tab over here, we can see the fans which are not connected. What's funny enough or weird enough that CPU fan is not demonstrated and not monitored here, it's only the system fans. Then down here in the normal sensor section we can see some temperatures and the fan speeds. These fans are rotating at 100% speed, and unfortunately I didn't find any way how you could update that through IPMI or BMC interface. For example, I can click on fan 2. Here we can see this kind of RPM chart, which is not really indicating anything, and I would say it is broken, or maybe it will update over time, I don't know, but the current speed is 1360 RPM, it does not change. Down there you can see a bunch of fan history events, but it is pretty much useless. Okay, other than that, you can't really do much on the sensors page. You can only see the fan status and the temps. Now in the logs and the reports we have a bunch of subsections, IPMI event log, and here we have all sorts of possible logging, and you can also download their logs to your computer and investigate there. System logs, here we have some kernel information and kernel logging. Again, if your computer acts out, it might be useful for debugging purposes, but other than that, it doesn't really give much. Audit logs, yet another section of logs. For example, here we can see that user admin signed in to the IPMI interface, and that's me. Video log, here I don't have anything and I'm not entirely sure what it is for. Maybe it will list here all the video recordings once I record something from the page. Settings, they're supposed to be the most interesting page, but unfortunately we don't have much control over the motherboard through BMC. Captured BS-DOS, these are basically screenshots of blue screens of death, and I suppose that BMC is supposed to capture these automatically, but so far I have none. Then we have date and time, which is pretty standard for all BMCs. External user services, so you can set up Active Directory and other sorts of authentication authorization for your users. KVM mouse settings, and here we can pick either relative positioning for Linux, absolute positioning for Windows, and then other mode. Log settings, we have log settings policy, and then we have advanced log settings policy, so basically everything related to logging. And then we have a media redirection, so we can create some virtual CD or DVD drive and provide some media to our BMC. Virtual media instance settings, so we can select how many CD drives, hard drives, and remote CD DVDs or remote hard drives we want to have, and a remote session. So we could have a remote session and do different kind of keyboard layouts. Again, something useful for administrating your server, but not more than that. In remote control, we can use either HTML5 KVM or we can use Java client. I prefer to use HTML5 one, and it works just fine. For example, right now I just booted into the BIOS and waiting while I'm recording this BMC video, and here we can do pause video, refresh video, display off. Then we can have mouse settings, other sorts of options. For example, I can zoom in even more, or zoom out. Unfortunately, zoom doesn't really work as intended in these kind of virtual access environments, but it is there. Then we also have quality settings, keyboard settings, send custom keys which you would not want to press on your own computer, hotkeys, video recorder, and then of course we have the standard power actions such as reset server or immediate shutdown or power cycle the server. In the active users we can also see who are connected to the BMC, and right now it's just me, admin. So I can navigate through the BIOS using my keyboard connected to my computer, so that works and no questions or problems here. All the BIOS settings are available, and of course I can adjust everything through the BMC using the BIOS interface. But if the motherboard doesn't work or you have applied wrong BIOS settings, of course you will not be able to enter into the BIOS to adjust that, even if you have BMC functioning. The next section is called image redirection, but this is actually about installation media images, like if you have an ISO image or something like that. I guess you can upload here some images for ISO CD, DVD, HDD drives or whatever and redirect it somehow. I'm not quite sure how that works, but if you need it, it's there. Then we have power control, and of course we have all the required power settings, power off, on, cycle, reset, and shut down. In the maintenance section we don't really have much interesting, but we can back up the configuration. We can either back up everything or in parts. Then we have a section called Firmware Image Location, and here we can pick either upload during flash or TFTP server. I think this is a pretty weird name for this section, but basically you specify here where you want to get the firmware image during the flashing. Either you want it to upload through web, or you want it to automatically get the image from a TFTP server. So if I pick TFTP server, it will ask for the server address, name, and retry count. Then we can also take a look at the current firmware version. So the current build date is 2024, and the version is 101.0. I don't know if Huananzhi has any better versions for this BMC, or maybe we can use some OpenBMC, but this is the current version. Firmware update is obviously the flusher to flush the firmware of the BMC, and I just remind you that Huananzhi H12 has a Speed ST2500 BMC on board as an expansion card. HPM firmware update, I believe this is BIOS update, so this can be used to update BIOS of your motherboard, but I might be wrong. Again, it is possible to just select file from your computer, upload it through web browser, and update BIOS of your motherboard. I have not tried this function myself, so I can't say if it works well or unwell, but at least it's there. Preserve configuration is another section which allows you to lock in configuration so it can be stored and restored after firmware updates. Restore configuration, just as it says, you need to specify previously backed up configuration file, upload it, and BMC will restore the settings previously backed up. And finally, we also have restore factory defaults, which can be used in case when you messed up your settings and you just want to go back to some normal working state. The last system administrator menu item gives you an option to enable or disable sysadmin user and also set password for this user. In my case, I don't even know what is the password, but the user is enabled. Unfortunately, this is everything Huananzhi H12 BMC can offer. Yes, it's not advanced, but it's better than nothing. Now it's Proxmox time, and with my Huananzhi H12 motherboard, I have tested the latest Proxmox virtual environment available at the date of testing, and that one was 8.4.1. With Proxmox, I basically wanted to test two main features. First, check if IOMMU groups are available, if they're working properly, if we have enough isolation, and second, if GPU or PCI Express devices pass through is working as it is intended. And I'm glad to report that both of the features are working fine. If you want a bit more details, then just stick in, because here I'm going to drop in another pre-recorded piece, me walking through my Proxmox setup with the GPU pass-through. GPU pass-through is another thing people ask me to test with this Huananzhi H12 motherboard, and I'm happy to inform you that it works just fine. So here is a little guide on Proxmox how to set up GPU pass-through, and I didn't even have to follow this guide. I just created my VM. Over here I have Windows VM, and it has a couple of PCI Express devices which I am passing through. The first PCI Express device that I am passing through is my 4TB SSD, where I have all the games installed. And the second one is the primary GPU, which is my AMD RX 7900 XT. Setting everything up was pretty simple and straightforward, just using the Proxmox UI. Nevertheless, let's go to the console and execute these Proxmox guide commands and see what kind of output we get with Huananzhi H12 motherboard. First, let's execute this one verification if IOMMU groups are enabled, because here I get a bit of a weird answer. So we get a bunch of different IOMMU outputs, but we do not have this one which is specified by Proxmox guide, that IOMMU enabled shall be somewhere there. It's not there, but nevertheless we get lots of these AMD IOMMU numbers, so I suppose it's working. Also, if we go to the second section, which is verifying if interrupt remapping is enabled, we get the expected output. As you can see, AMD virtualization interrupt remapping is enabled, so that's all good. And finally, I can also list all the IOMMU groups using the following command, again from the Proxmox guide. So here is a gigantic table with all of the IOMMU groups, and as you can see, there is lots of them, and it seems like every device is coming into its own group, so isolation and pass-through shall be pretty easy. So for example, this is my RX 7900 XT. It comes into group 74, and then I also have RX 6400 installed, which is coming to group 22. This one I use as my primary GPU. This one is pass-through GPU for my virtual machine. And this is the onboard ASPID graphics, which is also coming with its own IOMMU group. The same applies to the SSD drives. Right now I have two of them installed. Let me see if I can find them. Where are those SSD drives? All right, all the SSDs are at the very top. So this one, Crucial P2, is my 4TB NVMe SSD with all the games installed. It's coming to its own group 17. Then we have another SSD where I have my virtual machine installed. This is Samsung 970 EVO. It comes to group 18, and finally I have this Samsung SM951 OEM SSD, which is Proxmox installation, and this is IOMMU group 19. So far from what I can tell, the IOMMU groups and GPU or PCI Express pass-through works just fine on Huananzhi H12 EPYC motherboard. I have also tested USB pass-through, and that worked just fine as well. And before I move on, let's actually take a look inside the virtual machine I have set up and passed through my PCI Express devices. So this machine has only 8 EPYC cores, which means we have only 4 physical cores and hyper-threaded to 8 threads. And then main board, we see that this is emulation from Proxmox. Memory, we have only 16 gigs in this virtual machine. SPD information is of course not available as this is emulated through Proxmox. And the graphics, CPU-Z does not detect it properly, but GPU-Z does detect it. Benchmark numbers are pretty irrelevant here, but with just 4 EPYC low-clocked cores, you don't get the best scores, of course. Looking at GPU-Z, we can see that PCI Express connection is not properly detected, but the GPU is fully detected, and the sensors we can also see, and I can also do rendering, and the GPU is utilized and used when rendering something on the screen. Also, we can see that resizable bar is enabled. So GPU pass-through of my RX 7900 XT works just as expected. The same can be said about my PCI Express NVMe SSD drive. So this is system drive, and this one is emulated. This is a virtual disk created in Proxmox. And then if we look at the D drive, this one is a direct pass-through of my entire Crucial P4 SSD, or it was P2, I don't remember. Anyway, it's a Crucial NVMe SSD for 4TB. And as you can see, everything is detected transfer mode and all the details, because this device is not emulated and directly passed through to this virtual machine. After successful setup of GPU pass-through with my Huananzhi H12 motherboard, I decided to level up and go to GPU virtualization or GPU partitioning or SR-IOV. And for that, I have got myself an NVIDIA GTX 1080 that can be partitioned with a GPU unlock script. Again, here I have a pre-recorded video where I walk through my GPU partitioning setup, but there I forgot to mention that for SR-IOV to work with a GTX 1080, you need a specific match of Proxmox kernel and NVIDIA drivers. So in particular, even though I used Proxmox 841, I had to use another kernel, and that kernel is 6.5.13-6 PVE. And the exact GPU drivers are used are NVIDIA drivers 16.4, and the version is 538.33. Originally, to get this working, you would need an enterprise-grade NVIDIA GPU with some licensing, but good people figured out how to make it work on consumer-grade GPUs. And that's all thanks to this genius script, which was written way back in 2023, but still works today. Link to this script will be, of course, in the video description. But in general, or in short, the script contains all the necessary steps and all the necessary information. It installs all the necessary packages. Originally, I had some struggles getting it to work because I had not clean Proxmox installation. After I did clean installation and executed the script from scratch, everything worked from the first try. So in this window, I have NVIDIA SMI monitoring status of my GTX 1080 with 1 second interval. And as you can see right now, the GPU is idling. Now if I go and take a look at my GPU, inside here I have GPU Z. And GPU Z reports that my GPU is NVIDIA Grid P44Q with 4 GB of video memory, because I have used vGPU profile with 4 gigs of memory. There are different vGPU profiles and I will take a look at them in a second. But right now let me start this stress test or graphics rendering test of a GPU Z, and then we can go back to the monitoring part of NVIDIA tool, and we can see that the GPU is getting to do some work. The clock frequency is going up, the memory frequency is going up, and the GPU utilization is obviously going up as well. And that's because this GPU is rendering this little GPU Z rendering test. If I open Task Manager in this virtual machine, we indeed can see that we have a GPU 0, which is NVIDIA Grid, and it has 4 gigs of dedicated memory. The rest of the stuff is pretty much the same as with the previous VM. I have 8 virtual cores of my AMD EPYC CPU, 16 gigs of RAM, SSD, and Ethernet adapter. So, to conclude, I can say that SR-IOV or GPU partitioning works with Huananzhi H12 EPYC motherboard. Finally, let's take a look at my hardware configuration for the VM. So over here I can add the NVIDIA GTX 1080 as a mediated device. Here I need to select the GTX 1080 in the raw device input, and then in the MDev or mediated device type I can select multiple different or I can select one from multiple different vGPU profiles that are provided by NVIDIA. And you can see that there are different profiles, and some of them are going beyond what's available in video memory for GTX 1080. Here we have 24 gigs of video memory, which is obviously not possible since 1080 has only 8 gigs of memory, but that's probably because the GPU is pretending to be NVIDIA Grid P40. Other than that, we have 2 GB profiles, 1 GB profiles, and then 3 GB profiles and 4 GB profile. I currently use this 4 GB profile, but then you can go to 6 and 8 gigs of video memory if that suits your needs better. The last few questions I have to cover are pretty short. The first one is about Unraid. Someone asked me if I could test Unraid installed on a USB flash drive with a Huananzhi H12 motherboard, because it seems like Unraid might have some issues with certain USB controllers on certain motherboards. Here, I'm glad to report that Unraid worked just fine if I install USB stick into USB 2 port or USB 3 port. I didn't see any errors, any issues. I successfully created a pool, I successfully copied data to and from the pool, and it worked just fine, so I don't know what else I can test, but it just works. The last question to cover is about the VRM fan on Huananzhi H12 motherboard. Can you replace it? Yes, you can replace it. The fan is 30mm in size and 10mm in thickness. The fan also takes 5 volts as input. In comparison, the Huananzhi X99TF, T8 and F8 motherboards have a 30mm fan but with a 7mm thickness and with a 12 volts input. So if you're looking for a fan for H12 motherboard, then make sure that it is a 5 volt input fan, because the 12 volt fans might spin very slow or don't spin at all with 5 volts input. And this is all I have for part 2 of my Huananzhi H12D-8D motherboard review. After additional testing, my view on this motherboard did not change. It seems to be a pretty decent motherboard, and so far I did not get any quality issues, I didn't get a single crash, the motherboard was rock solid and rock stable on me. Yes, there are some certain limitations and certain features which are missing that we would like to have, but all in all, if you need a server AMD EPYC motherboard and you're willing to risk with the Chinese hardware, this seems to be a pretty solid alternative to expensive Supermicro ASRock or Gigabyte boards. Of course, if you're able to find ASRock or Supermicro board for about the same price with the support for AMD EPYC 2nd and 3rd gen, then I would always recommend to go with the established and reputable brands. With this, I have to say thanks for watching, thanks for listening, I hope it was useful, and see you in the next videos. Bye bye.